When we are controlling LED current, that is forward current of this optocoupler LED, IRED, it is controlling the output current, that is collector current. Now if I will adjust the resistor, we are controlling the brightness. Optocoupler, opto-isolator. What is optocoupler? How an optocoupler works? What is CTR? That is known as current transfer ratio. We will discuss in detail how to test optocoupler and what is its main role in power supplies in voltage regulation. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. When we see different circuits, power supply circuits, chargers, we see a small tiny component that is connected between output side and input side, secondary side and primary side. If you see a set of 5 optocouplers that are connected between secondary side and primary side. Same way in this circuit, 4 optocouplers. 3 optocouplers here. In this circuit, 3 and 3, 6, 7 optocouplers are connected in this board. As a reference, we are discussing CNY17F-2. When we have switching power supplies, any power supply that are not using any transformer, that means line voltage will enter in that circuit, that will be rectified. So this circuit is unisolated. Then these voltages are processed with high frequency and these are passed through a transformer that is called high frequency transformer. We will receive output here. Why we use this combination? It is used to add power saving and make a smart regulation. Now until here, this circuit unisolated primary side, and this circuit is providing isolated output using this transformer. We are taking output in this side, output side. We need information what is the exact value here that will be transferred here. Here we are using transformer that is providing isolation, isolated voltage, that are separated voltage from the primary side, because a transformer works using magnetic flux lines. Then another component is connected here that works on optical light. We add some information here in this portion and we receive that information, and there is infrared light or visible light that will be transmitted from this side. It will reach here and it will provide a feedback signal to this control circuit. So if the voltage are increasing, it will provide feedback that the voltage are increasing. This smart switch will decrease its switching, it will decrease its magnetic flux in the primary side. In result, output voltage will decrease. If the output voltage are decreasing, it will give feedback that the output is dropped. So it will increase its magnetic flux by increasing its switching cycle so that output voltage will be maintained. As I said, we have a light source that is being transmitted from one side to the second side. That means we have any LED, IRED that is transmitting some light. When we are dealing with light, phototransistor is connected here. Without base. When this light will reach at its base, it will conduct. This is the basic phenomena of this optocoupler, that current will flow in this portion and it will control current in this portion, and there is just only optical line of sight between these two parts that are encased in a pipe, in a tube, in a box. In this chip, one side LED, or we can say IRED, and second side phototransistor. When it will receive light, because there is no other source for light, because it is encased in black epoxy, so it is totally dark. Just only it will receive light from this diode. When current will flow from here, from anode to cathode, this transistor is connected in any circuit. This is connected in one circuit, and this portion is connected to second circuit. So both circuits, high voltage section and low voltage section, are now separated. Here is magnetic flux, here is optical line of sight. No physical electrical connection between these two portions. It is the basic that it is composed by two components, LED or IRED, phototransistor function. It receives some voltage. Forward current will flow here, that is called IF, forward current, and VF, forward voltage. When this line is connected to positive voltage, this is connected to negative battery side or any power supply, it will allow current. How much current will flow in this path? That is a big question mark. Then this circuit is connected to any feedback loop, any circuit, optocoupler. Phototransistor output, no base connection, 6-pin IC. Sometimes we see 4-pin IC. Sometimes we see 8-pin ICs. There are SMDs, different packages. The working concept will remain same. Sometimes one optocoupler in one body, sometimes 2, 4, 8, depending on the requirement. Pin 1 anode, pin 2 cathode, pin 3 not connected, pin 6 not connected, pin 5 collector, pin 4 emitter. Here is very important point to understand. CNY17F, it is a family. Then there are different numbers. If you see this data sheet, CNY17F, this is part number, dash CTR. What is the CTR? Current transfer ratio. We will discuss now. Just see this table. Package, DIP6, SMD6, different package styles. CTR percent, 40 to 80. Part number will CNY17F-1, 63 to 125. It is CNY17F-2. If we need CTR 100 to 200, then F-3. CTR between 160 to 320, F-4. CTR, current transfer ratio. When we are discussing any power supply, just for example, we say 3843 ICs, 3842, 3845, depending on switching frequency, at which frequency we are designing any converter, error amplifier for that IC will respond to this speed, that how quickly it will change its switching cycle. If switching frequency is low and we are demanding function very fast, this IC will not respond. If it is switching very fast and we are designing any feedback loop with slow response, there will ripples. For a best design, error amplifier current must be considered carefully. in datasheet, in application notes, there is mentioned that 384 series 100 CTR. We can say 90 to 110. Center value 100 CTR is excellent. Let's suppose I need 10 milliampere here in this portion. How much current we will apply here? Because its transmitted light and its conduction are calculated, that are predefined by any manufacturer. In this table, IC, collector current, that is output current. Output current divided by input current, IF, multiply with 100. It is CTR, current transfer ratio. If our power supply needs 100 CTR, that time we will use F-2, 63 to 125. If we will use this one, that is CNY 17 F-1, it will not work properly because it will not provide required current to the next circuit. In simple words, we can say it is gain. What is input? What is output? It is a ratio. So optocoupler works on a transfer function, on a calculated function. If I need 10 milliampere current and I apply 10 milliampere in primary side, 10 divided by 10, 100 CTR. Let's design it practically. If I will design this circuit at 10 milliampere and I connect a resistor here that will allow just only 5 milliampere, that time 5 to 200 CTR, that time CNY 17 F-2 will not work because its range is maximum 125. If you check its datasheet, IF, forward current maximum 60 milliampere, that is this current. And if we see output side, collector current maximum 50 milliampere, that are absolute maximum ratings. This is the highest amount, and this is the highest amount of current in primary side, in LED side. Transistor side 50 milliampere at 70 volt VCE. So we can say, to work within safe range, this side 40 milliampere and this side 50 milliampere maximum. Normally it is designed at 5 to 10 milliamperes or less than that. Now we will see it practically. I have LED. A simple rule. What are the voltage here? I have 5.12 volts. We will use two power supplies, CNY F-2, 5.12 volt. When 60 milliampere current will flow here, 1.3 volt to 1.6 volt will drop across this LED. We will consider the minimum limit, 1.3 volt. I will allow 10 milliampere current to to design it. 5.12 volt minus 1.3 volt, that are LED voltage, divided by 0.01, 10 milliampere current. 382 ohm resistor will be connected here. 5.12 minus 1.3, 3.82. 3.82 volt divided by 330 ohm resistor. If I will connect 330 ohm resistor instead of this one, 11.57 milliampere current will flow in this channel. This is good. If we are designing to take specific CTR, that time we will use 382 or closer value. But now I will use 330 ohm resistor. 337, that's good. With tolerance, okay. Pin number 2, cathode. Pin number 1, anode. DC milliampere. We can say it is exactly our required value. We connected voltage source here with controlled resistor. Okay. If I will set multimeter to a resistance, and I connect between pin number 4 and 5, that are collector pin and emitter pin, black lead at emitter, red lead at collector, it is showing open circuit. When I connected voltage source here, the output resistance is 200 ohms. That is a resistance here between these 2 points. So transistor is turned on. Now I will use another power supply here in this portion. We will use separate power supply. .2 volt. Positive to the collector pin. Now if I want to turn on LED here as a visual result, 12.2 volt. In normal transistor, collector to emitter voltage are 1 volt, 1.3 volt, but in this 0.3 volt, that are VCE saturation. 0.25 volt to 0.4 volt, normally 0.3 volt, that are saturation voltage. 12.2 minus 0.3, that is a nominal value, minus LED 1.8 volt, minus 1.8 volt, 10.1 volt. We need a resistor here that will consume 10.1 volt. LED maximum current 10 milliampere divided by 0.01, 1010 ohm resistor. We will use nominal 1 kilo ohm resistor, that is good resistor. Long lead anode, short lead cathode. It is 1.78 volt. We considered 1.8 volt, good. We will connect anode to the emitter pin, that is pin number 4, and this is pin number 5. This is pin number 1, this is pin number 2. Cathode of LED resistor will be connected here. We will connect a resistor second side to this power supply negative line. Now you can see the LED is powered on. We provided a power supply in this channel, that is transistor side. LED is powered on. If I remove this side, the second side is disconnected. We can say it is working as a relay. It is switching function. We provided 5 volt to this channel and the output is turned on. How much current is here? We consider 10 milliampere. How much current is here? 11.57 milliampere. Output current 10 divided by 11.57, 0.864, multiply with 100. CTR for this circuit is 86.4. 10 milliampere over 11.57 multiply with 100. That means if current will change here, the output current will change with the same ratio. If I connect 10K potentiometer here in this channel now, $5 volt here, this resistor will remain same 330 R, and we will add a potentiometer here to control the primary current, forward current. I will use 10K potentiometer. If I will use 10K potentiometer, 5.12 volt, we will consider the same voltage. Practically voltage are 5.15, no problem. 5.12 minus 1.3 volt for LED, IRED. Now if resistor will remain same, if we will adjust this potentiometer to 0 ohm resistor, that time the maximum current will 11.57. Remaining voltage are 3.82, 330 ohm plus 10,000. Multiply with 1 million. The current will vary from 36 microampere to 11.57 milliampere. Now with the same ratio, 11.57 multiply with 0.86 that we calculated here. If we will set this potentiometer to 0 resistance, that time 11.57 current here, multiply with this ratio, that is 0.864, which we calculated here, 0.864, 9.99 milliampere. If current is 36 microampere, when we will adjust this potentiometer to maximum, 36 micro, 10 raised power minus 6, multiply with 0.864. The current will (31 microampere). With the same ratio, the current will flow in the secondary side. This time the LED is off. Now if I will adjust the resistor, we are controlling the brightness with the same ratio. With that CTR, the output current is increasing or decreasing. This is role in power supply. When in any power supply, this is secondary side and here is RL. We are sensing voltage from this point. In half cycle, when it will switch, it will store voltage in the magnetic core. Then it will transfer voltage in this capacitor. This capacitor will run load. When it will run load, the voltage will decrease. When voltage will decrease here, same will reach to optocoupler. Optocoupler current will change. How? With this ratio. When this current will change, the same ratio is being transferred in the secondary side. With this changing light, with this changing current, PWM controller will understand what is the change, what is the load side in the output. So that will control its duty cycle to control the output voltage. So this is a role of optocoupler in any power supply. We discussed basics. What is optocoupler, opto-isolator? It provides isolation. It separates secondary side and primary side. Then how it works? What is CTR? That CTR is current transfer ratio. It is a calculated ratio between output current and input current that is defined in the data sheet. That this optocoupler, this family name, this number will work with this range to this range. Then how to test? The same combination will be used as a test circuit. We are controlling primary side, this side, and it is controlling output side. If we will connect any microampere meter or milliampere meter in the output side, we will measure the current. If we are feeding to any analog circuit, any error amplifier, that will adjust the output. And its role in power supply, that it will sense the voltage at output terminal, its light will change, that is being transmitted from its LED, that will affect on the optocoupler transistor. So transistor conduction will change the voltage level in the output circuit. Let's see practically voltage here. Emitter pin, This time at 10 milliampere we are receiving this voltage value. If we will control the current, we can see the voltage are dropping now. When there is maximum resistance, the output voltage are just only 1.7 volt. Maximum voltage are being dropped across this transistor. We are increasing the current in this LED and it is increasing the current in output side. So by controlling primary side current, forward current of this optocoupler, we are controlling the output side. If you are new to my channel and you enjoyed this video is informative for you, then don't forget to subscribe it. If you enjoyed it, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.